So on the next page, they want us to do the same thing, except this time we're working with spheres, and this time my dimensions are getting smaller. We're still going to look at a multiplier to figure out how we get from 12 to 6. We're not going to say that we took half of it. Well, we are going to say we took half of it, but we don't generally think of taking half of something as dividing by 2, even though that's what we're really doing. We actually think of it as multiplying by a half. So we change, I calculated, I used these two formulas right here for surface area. I calculated all three of these. Here's my work for the 12. This one I just plugged in 6 right there. This one I just plugged in 3 right there. I got 576 pi, 144 pi, and 36 pi. We leave pi in there because it's easier to deal with the pi than it is to deal with all the decimals. It's easier to see the pattern. The volume was 4/3 pi times the radius cubed. So that's where I got this 2304 pi. I didn't write that down, but that's where I got the 2304 pi. And then, of course, I just plugged in 6 right here. And that's where I got the 288, and then I plugged in 3 right here, and that's where I got the 36. Now they want me to do the same thing. If I do a dimension change, notice my notation. If my dimension changes, triangle means change, by a half, how did my area change? So this one went by a half. So how did the 576 compare to the 144? I believe that is... it changed by 1/4. Okay, so if you take 576 and divide it by 4, you get 144. So instead of dividing by 4, we're going to multiply 1/4. I think the same thing happened right here because this is also a change of a half. This is a change of 144 divided by 4 gives you 36. So as the conjecture here is that as my dimension changes by a half, my areas change by 1/4. That's my conjecture. Okay, it says now use your conjecture to find if it has a radius of 1.5. So that would be the next half in my table right here. I take half of that one. Then for this 36 right here, I'm going to find 1/4 of that one. 36 times 1/4, I believe, will be 9 pi. So my prediction is that the surface area will be 9 pi. And again, of course, you can verify that by taking the surface area formula, which is 4 pi times 1.5 squared. And you type that in the calculator, and your surface area comes out to be 1.5 squared times 4 is, guess what, 9 pi. So now the next question down here, number 6, says we notice that the radius decreases, so does the resulting volume. Make a conjecture. Okay, so again, my dimensions are changing by 1/2. And what did my volume do? So find out the ratio between this 2304 and this 288. I'm going to make, I believe that's going to be 1/8, 2304 divided by 8. I did it wrong. 2304 divided by 8 gives me 288. So that's going to be times 1/8. And I think it's going to be right here, times 1/8. So again, of course, my next one will be 36 divided by 8. And it will come out to be 4.5 pi. And so the conjecture is that the volume will change by 1/8. And again, there is a connection between these two because it won't always change by half. Use your calculations to make a prediction. So my prediction is that the volume will be 4.5 pi. And of course, you can verify that. Okay, so for your assignment, on page, what are we on? Page 541, you need to do numbers 8 and 9, and then you need to do numbers 11 through 15. So 8 and 9, and then 11 through 15. After reading some of your questions, I want to make sure that you picked up on what we learned on these other pages. So when we had a volume change, I'm sorry, when we had a dimension change, this one right here had a dimension, and I'm using the letter D and the triangle to abbreviate dimension change. When your dimension change was by 3, our area change was by 9, and our volume change was by 27. And I kept mentioning that there was a relationship between these, but we never specifically spelled out what it was. So whatever this dimension change is, what's the relationship here between 3 and the 9? Isn't this one right here just 3 squared? Yes. And the way that you can keep up with the units that we were using right here was inches. When we're talking about the dimensions, it's 1 inch by 3 inch, and this was a 9 inch. The area is always listed in inches squared because we multiply an inch times an inch, we got inches squared. So this right here is how I remember that we take this number, the dimension change, and we square it because that's what we do the dimensions. The same thing right here, this 27 is the dimension change cubed, because for volume, our units are inches cubed. So whatever we do to the dimensions, 1 inch to inches squared or inches cubed, that's what we do to this change. We square the 3 to get 9. We cube the 3 to get 27. I believe the same thing happened over here. We had a dimension change of 1/2. That was the dimension change. The area change was 1/4. If you take 1/2 and square it, you get 1/4. This one was 1/8. If you take the dimension change of 1/2 and you cube it, 1/2 times 1/2, 1 times 1/2, you get a dimension change of 1/8. So it doesn't matter over here. That's why I said if the dimension change is by k, by some multiplier, whether it's a fraction or a whole number, the area change is going to be by k squared, and the volume change is going to be by k cubed. So that should help you get these problems worked.